Welcome to qnawire.
In this question, it is given that a man has fallen inside a ditch, and two of his friend is pulling him upward using two ropes as shown in the figure. So we have to show in the first part that as the man rises up, the value of the force on each of the string will increase. In the second part of the question, we have to find the value of the force on the string when the man is at a depth of small h from the upper level. Okay, so to answer this question, we will just take the simplest form of this particular situation as it will be shown in the right side. So as you can see, the man who is inside the ditch has been replaced by a block of mass small m, and let's say on the two string the two friends are pulling with a force of F as shown in the figure. So we have to show that whenever the block moves upward, then the value of this F force will also increase. Okay, so to show that, let's assume that this is the midpoint. Of course, this is the middle line of that is passing to the center of the block. So if this angle is theta, then by symmetry you can say this angle is also going to be theta. Now as the two strings are inextensible, so at each and every point of the string the force is going to act same. So on this string the force acting is F. On the left side string also the force that is acting is F, let's say. Okay, now if we take the components of this force, then each of the force will have two components. One will be along this dotted line, so that we can write as F cos theta. So for both the forces, the two component will be 2F cos theta in the upward direction, and their horizontal component will be in this direction. For the right side string it will be in this direction, that is F sin theta, and for the left side string again it will be in this direction, that will be again F sin theta. And since the two horizontal components are in the opposite direction, so each of them are going to cancel each other. So on the block you can say the net force that is acting in the upward direction is 2F cos theta, and one more force is also acting on the block in the vertical downward direction, that is mg. And for equilibrium we can write that for equilibrium of the block, in bracket I can write of the man, because as I have represented the man in terms of block. Okay, so for equilibrium of the block at any instant, like at any instant when the angle made by the string with the vertical is theta, then we can write that the net force on the block in the upward direction will be 0, and that is true if 2F cos theta is getting balanced by mg. And from here I can write F, the force on each string, is going to be equal to mg by 2 cos theta. Okay, now one thing that we can see from here, that if we keep if the two friends keep pulling the two strings upward, in that case the block or the man will start moving upward, right? In that case, as the man start moving upward, so the theta, the angle between the string and the vertical direction, will also increase. Yes or no? So then we can just conclude one thing, that if the man is moving upward, the angle theta will also increase. Correct? As theta increases, we know cos theta will decrease. Okay, so from here you can just say that as the man moves upward, as cos theta is decreasing, so f is going to increase, right? So then we can just write it over here. Thus, as the man moves upward, the force on each string will increase because cos theta will decrease. So this is the proof for the first part of the question. In the second part of the question, so we have to find the value of force when the depth of the man is h. Okay, so let's try to see that situation with a diagram. So as it is given, the width of the ditch is d. So from the figure I can say that this distance will be half of that, which is d by 2, and this angle is theta, and we're given that the depth of the man from the upper level is h. That means basically we're given this distance as h. So from the figure then we can easily calculate cos theta. Cos theta will be equal to base, which is h, by hypotenuse, that will be square root of this d by 2 whole square plus h square. So this will be equals 2h by square root of d square plus 4h square. So from the previous part of this question we can then write the force on the string, which if we calculate the force on a single string, that is f we can write as what, mg by 2 cos theta, and in this case as you can see cos theta equals 2h by square root of d square plus 4h square. So I can write this as mg by 2 times 2h, and this square root part will be going to the numerator, that will be d square plus 4h square. So on simplifying this we will get f equals mg by 4h square root of d square plus 4h square. So this is the answer for this question.